Here we go into our final real unit. Of course, well, hopefully, there's going to be a bonus unit, but our final real unit, unit number 7, trig functions. And we're going to talk about periodic behavior for this first lesson. Our learning goals, we're going to explore graphs with repeating patterns and then interpret graphs using key terminology. So this first lesson is an introductory lesson, going to be a lot of definitions, terminology, explanations before we kind of get into the main focus leading into our next lessons. You don't have to bother copying this down. We're just going to talk about this. So I'm telling you right now, these functions are considered periodic. And I want you to look at those and tell me if you could come up with the why. So these are periodic. Take a look at all four, maybe pause it, think about it for 60 seconds. Is there anything you notice about those four graphs as to why, even if you don't know what the word periodic means, you're kind of coming up with the definition in reverse, right? Instead of me giving you the definition, you're trying to figure it out based off this picture. So maybe you were thinking that they have a repeating pattern. So if you look at your top left graph, this definitely has a repeating pattern. This has a repeating pattern. Bottom right has a repeating pattern. Even the bottom left one, it's kind of hard to point it out, but it definitely has a repeating pattern. And the key to this is it has to have a repeating pattern over the same interval. So that's our definition for periodic. And this is the first thing you're going to want to copy down or put into your notes, that a periodic function is one that has a repeating pattern over the same interval or over the same domain. So I'll decide this in here. So periodic means repeating pattern, which would be your y values, over the same interval. And this would be your x values or your domain. So if you look at the top left, repeating y values every 4 units on the x. Top right, repeating y values every roughly 6.5. Bottom right, repeating y values every 1. And if you look at the bottom left, if you follow through, basically we start here, go through all that, blah, 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 and we end up back at the starting point again. So every roughly 6.5. So again, for something to be periodic, has to have a repeating pattern, so your y values, on the same interval or domain. So it can't repeat like, say, 4 units, and then the next one it still repeats, but it repeats over 6 units. So it has to be the same every single time. Some terminology. So these are definitions to copy into your notes. A peak, which will also be referred to as a maximum, is the highest point on the graph, and of course, that maximum point can repeat over and over again. So there obviously isn't going to be one maximum. A trough, also going to be referred to as a minimum, is your lowest point on the graph. Periodic, we just wrote that one down so you don't have to rewrite it. Repeating pattern over regular intervals. A periodic function. That's a function with y values that repeat a pattern over a set interval or distance. A cycle is one complete repetition of a pattern. So a cycle, how long it takes to go from start to finish once. The period is the time or distance, so whatever your x-axis happens to be or whatever your domain happens to be, the time or distance it takes to complete one full cycle. The amplitude, that is the area under the curve, or half the distance from max to min. And this actually has a formula, and I'm going to give you two formulas here for these last two. Our last definition, the equation of axis, is the equation, and it comes in the form of y equals, or f of x equals, for the halfway point between the max and min values. So we're going to come up with, or write in a couple of quick fire definitions here. The amplitude equals the max minus the min, all divided by 2. The equation of axis, and to save yourself some time writing, EOA equals max plus min divided by 2. So amplitude, max minus min divided by 2. Equation of axis, max plus min. Amplitude, the distance under the curve. Equation of axis, the halfway point between the max and mins. And we're going to be doing these types of calculations basically for the majority of this unit. You don't have to copy these down. I mean, you can. You can just follow along. We're just going to do them relatively quickly. So we're going to examine whether each graph is periodic or not, and if it is, state the period and the amplitude. To make life a little bit easier on ourselves, we're just going to say that this only goes up to 3. So, looking at our graph on the top left, is it periodic? Does it repeat over a set interval? The answer is yes. It basically repeats every, again, just so we all have the same note, or if you're just paying attention, it would be a guessing game here, but let's say 6.2. So I start here, I go up, across, down, 6.2, repeat again. If I go to the left, so start here, go up, across, that's 6.2. That would be like negative 6.2. And then up, across, back down, 6.2, definitely periodic. So definitely periodic. And we want to state the period and the amplitude. So the period. We just came up with that, 6.2 units. The amplitude, remember the amplitude is the distance under the curve, halfway. Or, so we're going to start using our formulas. Max minus min divided by 2. So my max is 3. My minimum is 0 divided by 2 equals 1.5. Top right, is it periodic? Looks like it, right? Let's say, for argument's sake, that is negative 6.5. So we start here, go up, oops, make this little W shape, come back to my starting point, and we repeat the exact same process. And again, it takes 6.5 units. And we'll say that goes as low as -1 and as high as 0.7. Our period, how long does it take to complete one cycle? We'll say 6.5 units. My amplitude is max minus min divided by 2. So my max is 0.7. My min is -1. All divided by 2. I'm going to erase that 6.5 just so it doesn't confuse anybody looking at this later. So one thing you're going to want to be careful is when your minimum's a negative, don't forget amplitude is minus, and minus a negative, two negatives make a positive. So this is really 1.7, right? 0.7 plus 1, so it's really 1.7 divided by 2, which is 0.85. One thing you might want to add to your notes, amplitude can never be negative. Amplitude is a distance value, and you can never have a negative distance. So you might want to add that to your notes. Under amplitude, can never be negative, is always positive. Our graph on the bottom, maybe it kind of looks like it repeats to you, or at least has a pattern. However, those y values don't repeat. So like this y value never repeats, this y value doesn't happen again, this value doesn't happen again. Like it does, but not in the same pattern, right? It happens right there. So this is not periodic. It doesn't repeat over a given interval on your domain. And if it's not periodic, you can't find the period, you can't find the amplitude, you can't do any of the stuff that we want to do this unit to it. Example number 2, use the following graph about a Ferris wheel to answer the following. What is the period? Okay. Recall, the period is the time it takes to get from where you started all the way back. So we'll assume our x-axis is in time because you're on a Ferris wheel, and that would be height versus time. And so at 0 seconds, you start at 15 meters, let's say. Ferris wheel operator starts it. You go up, reach the maximum, start your way down, reach the minimum or the trough, come back up, and there you go. You're back to where you started, and the pattern repeats again. So what is the period? How long does it take? Well, let's say that's 6.5. It takes 6.5 seconds, or what is the period? 6.5 units. So I'll do my answers underneath. What is the period? 6.5 units. We don't know what it is. Could be seconds, that'd be pretty fast. Could be minutes, that'd be pretty slow. Who cares? On your test, you'll be given what the units are. A, done. B, what does it represent? So again, you envision yourself getting on the Ferris wheel. It moves around, everyone boards. You start at a height of 15. You go up to the top. You come back down to the bottom and go back up to where you started. So what does this represent? This represents how long it takes to do one complete circle of the Ferris wheel. So how long it takes to complete one, how long it takes to complete one, I won't write complete again, there'll be too many completes. We'll say one full revolution on the Ferris wheel. So how long it takes to complete one full revolution on the Ferris wheel, to go all the way around the circle one time. What is the diameter of the Ferris wheel? Let's add some things here to this picture so we all have the same note. Let's say that's 27. So the highest it gets is 27 meters. Let's say that's 3. The lowest it gets is 3. That's going to help us answer part C. What is the diameter of the wheel? Well, let's draw a little picture. Maybe that will help us, or a little visual. There's our Ferris wheel. There's the ground. The highest it gets is 27 off the ground. The lowest it gets is 3. Diameter is distance all the way across the circle. Well, what's that distance from 3 to 27? Hopefully you're thinking 24. We'll say meters. Why not? And D, at what times is the passenger at the top? Again, so we kind of have the same notes. And we're going to guess for these, but when it comes to your test, don't worry, they'll be on like exact values. You won't have to guess. Or we will look at different ways you can answer that in the future. But for now, they'll be on nice values. So let's just assume we're at the top right there. Let's say that's 1.5. And let's say, we'll say 1.6. Sorry if you wrote 1.5. We'll say 1.6. The issue with 1.5 is that we know our period is 6.5. And if I have 6.5 to 1.5, that would put me at 8. And if I look, my period's my maximum's just a little bit past 8. So again, we'll say that's 1.6 seconds. So when are you at the top? So you're going to be at the top after 1.6 seconds, or units. I'll just say seconds to make it easy. And then all you have to do to get the rest of your points is add your period, right? If it's periodic, it means it repeats. So every value will repeat that exact same distance. So we've already come up with our period at 6.5. So every 6.5, it will repeat. So if at 1.6 seconds plus 6.5 is 8.1 seconds. That's not too bad because we could pick that off the graph. Let's do another one. Add 6.5. That would be at 14.6 seconds, and so on. The big idea there is make sure you realize that you could just keep adding the period every time to get that value where it occurs. Example 3. Now I've given it to you as a table instead of a graph. The following table provides points for a periodic function. Clearly we can see that it goes 1.2, 2.4, 2.5, 2, 1.2. So it got back to the start and repeats the exact same thing over and over again. Looking at your table of values, what is the period? The period, hopefully you're thinking, is, and again, let's, I won't even bother giving it units. I won't bother saying seconds or meters. We'll just say units. What is the period? How long does it take to go from the beginning to the start? Or to get back to where it was? So we start at 1.2. I get back to 1.2 at an x value of 8. So what is the period? We'll say 8 units. What is the amplitude? Well, we have our formula, right? Amplitude equals max minus min divided by 2. What's my maximum? 2.5. What's my minimum? 1.2. 2.5 minus 1.2, that's 1.3 divided by 2, 0.65. And again, you should never get a negative value for amplitude. C, what is f of 20? Well, you could keep repeating out that pattern. X is going up by 2s, you'd only have to write 2 more points. If you did that, you should get, so 2.4 would be the next one, 18, 2.5 would be the next one at 20. We're going to look at doing that another way in just a second. D, what is f of 25? Well, we could sketch that, I guess, but we don't know what happens in between those values of 2. I mean, you could guess, but you shouldn't guess for this type of question. You actually can't come up with what f of 25 is. Those are all even numbers. 0, 2, 4, 6, 8, 10. We don't know like what the value is at 1, 3, 5, 7, and so on, going up to 25. So there's actually not enough information to do this without guessing, and we don't want to guess from a table of values. Let's cut back to C. What if I gave you like, so I guess we'll do like C part 2. What if I gave you like f of, oh, I don't know, 98? Do you really want to repeat that pattern going all the way up to 98 for the x? I mean, it's doable. It's a waste of time. If I give you f of 598, it's even worse. So how can we figure that out? Some of you probably have a pretty good problem solving, I mean, you've proven you have a good problem solving ability. Maybe you're thinking something like this. I know my points repeat every 8 units. So if I do 98 divided by my period, what do I get? 98 divided by 8. I get 12.25. What that means is in 98 units, it will have repeated one full cycle 12 times, and then it'll get to just 0.25 of the next cycle, meaning a quarter. What is a quarter of 8? A quarter of 8 is 2. And if I look at my table of values, when x is 2, what is y? 2.4. We could have done the same thing for f of 20. So we could have done 20 divided by 8 gives you 2.5, meaning it'll have completed 2 complete cycles and then half of another one. Our period is 8. What's half of 8? 4. Look at your table of values. At x is 4, my y is 2.5, and that's what we got, 2.5. That skill alone will help you solve a lot of problems that you encounter throughout the rest of this unit. So that's kind of it for the introductory stuff for this unit. The focus of the rest of this unit that we're going to segue into right now is trig functions, because nothing that we just did had anything to do with trig, but it will from now on. Both sine x and cos x are periodic with a period of, so this is important information, 360 degrees and an amplitude of 1 unit. The equation of axis for both is y equals 0, or if you want to write it like this, f of x equals 0. On the bottom, I have a graph of sine x and a graph of cos x. That is what they look like. X-axis is in degrees, y-axis is just going up by ones. Sine is on the left, cos is on the right. As you can see, they both take 360 degrees to complete one cycle, hence a period of 360 degrees. If you try to calculate the amplitude, max minus min, 1 minus negative 1 is 2, 2 divided by 2 is 1 unit. Our formula for equation of axis, max plus min, 1 plus negative 1 is 0, 0 divided by 2, 0. So you want to make a quick sketch of both of those, and then I'm going to give you the key points, and we're going to use these key points. These are the parent points. So just like we did in the exponential function, just like we did back in the functions and transformations unit, we are going to be using txy's with parent points to transform these two graphs. That's where we're going with this in the next lesson. So let's start with sine x. Your first parent point is 0, 0. And then 90 degrees and 1. 180 and 0. And by the way, you can come up with these on your own. You can just type into your calculator sine 0, it's 0. Sine 90, it's 1. Sine 180, 0, and so on. Your next parent point, 270 and negative 1. Your fifth and final parent point for sine x, 360 and 0. Cos x, your 5 parent points, 0, 1. Again, you can calculate these just like we did for sine x using your calculator. Cos 0, cos 90, cos 180, if you ever forget. Our next one, 90 and 0. 180, negative 1. 270, 0. And then finally 360 and back to 1. So sine starts at 0, works its way back to 0. Cos starts at 1 at the max, works its way back up to 1 at the max. You need to know these. And by know these, I mean you should know them if we were in class. Obviously, virtually, they're going to be right in front of you. You need to be able to refer to these and be able to use them. That is it for your first trig functions lesson. If you have time, you are more than welcome to start the second one, as there wasn't really a ton to copy for this one. If not, that's okay. There is your seat work. Make sure you check D2L for any up-to-date questions they may have posted. That's it. Thanks for listening. Talk soon.